All right, welcome back. This is the Virtual Residency Workshop 2026. It's Tuesday, June 23rd. This is our second session of the day. This is intake interviews, both lecture and demonstration. And I want to introduce our speaker today, Dan Voss, from Corewell Health Research Institute. And take it away, Dan.
Hello, everyone. Thank you for coming to this talk today. And I want to say, I think I've been helping and doing this with Henry for almost 10 years now. And if you can see over my shoulder, there is a flat Henry that has also been showing up to these residencies and other events for about 10 years. So thank you, Henry, for hosting these and everything that you do. I also want to thank Dirk, who's on the call today, and we'll see him shortly. Um, this Cyber Ambassador project was funded by the National Science Foundation by both Dirk and Katie Colbury out of Michigan State. It's a professional skills workshop or training for cyber infrastructure professionals, and is based in the STEM, science, technology, engineering, and math fields. And it's a completely volunteer facilitators, an open source curriculum, which means if you want to use this or have this presented with your group or your university or wherever you are, it is open source. And I'll give you an email and contact for Dirk and Katie if you want to pursue some of these trainings for your own groups. And I just want to acknowledge that this is Katie and Dirk, and you'll meet Dirk's alter ego later in this presentation. This is a picture of Dirk's alter ego. And all right, so everyone that does this are volunteer facilitators. This is funded by NSF. And the background of this, it was started, Dirk was a campus champion. He was actually the person who onboarded me to the Campus Champions program. But Dirk and Katie used to teach for Tau Beta Pi. They have an engineering honor society that had a program called Engineering Futures, and it did trainings for the Tau Beta Pi honor society. But it was a copyrighted series, and so they couldn't extend the curriculum or update it to be more specific for what they wanted to do. So they wrote a proposal to NSF to build a whole new program from scratch with open source materials to train CI professionals, cyber infrastructure professionals. And they partnered with organizations from Software Carpentry, ACI Ref, Henry's thing, Mentoring Network, NIH, NSF, Exceed. And with all these organizations, they built this proposal and said, hey, NSF, can we make something that is open, available, and useful to more of our cyber infrastructure professionals? And they said, of course, here's all the money, make your course and go forth and send it to the world. So it is a total of 9 modules that covers communication, teamwork, and leadership, has over 24 hours of material, and it focuses on, so for the ACI Ref, I'm doing the first contact, communicating with a purpose, how to do an intake interview. And then tomorrow, our partner is doing Let's Talk, communicating with problems. But all these modules are available, and I'll give you the contact for Dirk and Kate if you want to use these or have these with your groups or somewhere else. And then one of the things that is very useful is um, it's learning by context, right? So skills across different areas like cyber infrastructure professionals or other professional skills can be taught. There are very common tools across all the disciplines, but they did it by context for this learning to be for cyber infrastructure professionals in the STEM education. So they focused on science, technology, education, and to make sure that these had specific scenarios that related to what you do in your daily learning and environment. So far, as of today, including, I don't think we've included your numbers yet, but there's been over 23,600 participants trained. There is a certificate program for the cyber ambassadors. There's over 1,000 people who have earned their certificates. People who do the training, facilitators like myself, there's over 178 of us, and then they've taught over 863 sessions. So one of the big ideas of things like this is um, Dirk and Katie will train people to go out and do the trainings for everyone else. So you can have this pyramid scheme of trainings to get out your information to more people. All right, so what's our agenda for today? So we're going to focus on how to do a good intake interview, and this focuses on you as a cyber professional, a cyber infrastructure professional, usually meeting with a researcher or a professor or someone who needs access to your to your um, to your environment. So we're going to do some example interviews that are recorded, and we're going to do some um, analysis of those interviews, and then we're going to learn the techniques you need to do to be successful with talking to and communicating with these researchers. All right, so for intake interviews, right, this is the first time you're meeting with someone and you're talking to a new researcher. You do not know them or what their problem is, and they don't know you or your resources. So we're coming into this blind. There is there is a your job is to help them with the research with your resources that you're in charge of and teach them or help to figure out what their problem is and how to best communicate what you can offer to them and what they need from you. Or if possible, maybe they don't need what you can offer and you can help them in other ways or do a handoff to someone who can help them with what they're trying to accomplish. All right, and so this is going to be interactive. So we're going to do chatter, which is we're open the chat window for Zoom, but you're not going to hit enter until we count down. So we'll test this in a second, but I'll say 3, 2, 1, chat. You'll hit enter and watch all the responses scroll through the chat window so we can see everyone's thoughts about the question or the responses we're looking at for the interviews or any questions we have. So let's do a test scenario. So open your chat window. I will open mine too. And we're going to, in after I count down, you're going to type in where in the world are you zooming from. So 3, 2, 1, chat. Wow, that scrolls very fast. So we have people from Boston, Minneapolis, Tennessee. Let's try to do coastal. What do we got? We got North Dakota. Oh, we got Phoenix too in Arizona, Milwaukee. No internationals yet. So everyone's US based. South Carolina, Delaware, Ann Arbor. I'm sorry, this is a Michigan State focused talk. So Ann Arbor, you're not allowed to join this cyber ambassadors talk. Uh, Seattle and Purdue. It's a good list of people. All right, so our chatter was helpful. So thank you for chatting, and let's start with the practice interview. So when you when you start a right, so we're going to start with a test session with a researcher. Her name is Lauren, and she wants to use your high performance computing center for her academic work. And so, how do we get started? So let's test our chatter with this question. So when I count down, we're going to type in a question you would ask Lauren for when she starts your intake interview for your HPC. So in 3, 2, 1, chat. All right. The first thing you learn is you got to scroll down in the chat to get to the new stuff. As Dirk says, we do love our University of Michigan's facilitators. I agree, Dirk. But sometimes there has to be rivalry within the state. Um, Good questions. Have you used HPC before? Tell me about your research. What tools you're currently using? Who's your PI? What experience do you have using computer resources? These are good questions. What discipline are you in? That's always very helpful too. Have you looked at our site for new researchers? Because you have online documentation for them to look at. Tell me about your project. Describe your research. Have you used other HPC resources at another institution? And tell me about your research question. I like those. The one thing I'm going to say is there was a gotcha here too. The first question is acronyms, right? Language, things from your specific discipline. What if Lauren has no idea what HPC is? So never assume if it's your first contact, um, your audience knows your language, your area of expertise. So always assume um, they they are new to this area. That was good. All right. So for the purpose of this training, how do we define an effective intake interview? So there are a couple of things you need to look for. One is you're trying to solve the problem, right? Remove the barriers, make it easier for the researcher and you to come to a solution. And then going to that solution, you have to implement a plan to solve the problem, right? Um, but the more important part is maintaining a relationship. You're here to build teamwork with the person, strengthen your connections, and then for build a foundation for your future success because you're not only solving the problem, but you have to make sure that this is someone you're going to be working with. And if it's a researcher, they usually have grad students, postdocs, researchers that work with them, and it'll be an ongoing relationship you have with them for helping them and you succeed for what you do and what they do too. And I like that, solve the problem and maintain a relationship. So good intake interview um, points, right? First, like you guys had in your chat, ask about the research. Don't rush through what they're trying to tell you. Listen to them, and then try to identify the problems that you're trying to solve. And because this is a cyber infrastructure focused training, right? Describe the problem in terms of the computing. How can this problem be solved using your infrastructure, your computers, your software, your people? And you need to assess their ability. Have they used high performance computing before? What is their computer knowledge? And in this world of people who have a lot of phones, they were born at a time when phones were more prevalent than computers. Do they know how to get onto a supercomputer? Do they know what command line is? Are they mainly using their phone when they go through websites, reading, doing things? So what is their ability? And then don't assume what your assumptions are and theirs about what you know and what they know about your setup, their research, and what they can do. And we'll go through some examples of this. Some of the examples that we have later for the intake interviews will highlight some of these good intake interview um, facilitation uh, ways. And one of the best things to do is, right, uh, when you don't assume for someone, you try to think of it, explain it to me like I'm a 12-year-old. Both the researcher and the facilitator, their research, especially at university, you're across so many disciplines, you can't understand all the nuances of everyone's discipline of the research. So always ask them for clarifying questions. Always make sure that you explain your your work, what you do, like you're also explaining to a 12-year-old, so they know that you don't make assumptions about what they know and what you don't know. All right, so one of the very important tools for this is active listening. So your goal is to really understand the speaker. So not just their words, what they're trying to say, but their body language. And I know this is more difficult in our world of zooming at things, but you can watch for body language. You can also hear in their voice if they're frustrated, worried, or anger. It's a process where you got to pay close attention and you try to reflect back to the speaker what you heard using I statements. So the best way to do this is what I understood was, and then you try to respond to them. The incorrect way is you said. So make sure it is what you understand when you reflect back to the speaker. And if there are strong emotions, right, acknowledge it, but don't judge it. The correct way to say that would be, that sounds really frustrating. Incorrect. Calm down. You're blowing this completely out of proportion. Right. So acknowledge them. You don't have to respond back with the same frustration. Right? That sounds really frustrating. Make sure you acknowledge them and what their feelings are, and know that it's difficult for them too. Maybe this is something that they have deadlines. Um, Things have to be done for proposals for grant deadlines. So you're here to help them, and they've come to you for to help them with their problem. Another tool. This is like the acronyms and what you assume, right? Reducing jargon. So before you speak, think about what you consider jargon and the discipline and background of the listener. There's also, right, universities are very culturally diverse languages. They mean in different languages. Got to make sure that if English is not their first language, make sure you understand that. And also the expertise of the listener. They might be very much an expert in their field. It doesn't mean they're an expert uh, in computing or how their field applies to computers or what they know. Or they might be very, very good with their in their field on their desktop laptop computer, and they can do amazing things there. But to translate that onto a supercomputer, HPC, or parallel processing, right, that's a whole different level. So you need to understand what they bring, what their expertise is, not only their discipline, but on your how it applies to what you do in cyber infrastructure world. Right. And so there's two ways to think about jargon. If it is important, right, you can use the jargon, but you must explain what the jargon is and how uh, you need that to solve the problem. So like HPC is a great example, right? So high performance computing. It is essential, often named to what you do. And what it means is you have a lot more compute power than your desktop laptop compared to something they understand. And you can connect computers together so they can work together to solve someone's problem. Or if the jargon is not essential, eliminate it. Don't talk about it. Get rid of it, and assume once again like you're talking to someone as a 12-year-old. Explain it to them like they have no background of what you're explaining. All right, let's do another chatter exercise.
Several high-impact AI opportunities.
I heard a question, but it was very quiet. Can you repeat that? Or maybe someone's microphone was accidentally on. All right. All right. So for our chatter, um, what are some examples of jargon we use as research facilitators? On countdown in three, two, one, hit enter. So many acronyms. GPU, MPI, CPU, OOD, uh, object-oriented devices, deep learning, cache, memory, disk, SSD, LLM, AI, nodes, cloud, Slurm, on-prem, allocation. All right, these are good examples. JBOD, just a bunch of disks. I like What happened? My computer said I oomed. How did you out? And for someone who doesn't know what is out of memory. I'm just proud I know what most of these things stand for. So yeah, right. So you need to explain to people, especially in this new world of LLMs and AI. Make sure you don't lean too heavily. A lot of people like to use AI as a all-encompassing term for anything under the sun, but in research, you have to talk about large language models and machine learning and the differences, especially if they're trying to use it. Your goal is never assume they know when they say AI what they want to do, or a GPU. I need a GPU. What are you doing? What are you trying to do? We scrozzled the DB. Okay, I don't know what scrozzled mean, but I assume that's not good. And TPUs too, yeah. Tensor processing units, right? Ops lingo. All right, those are good examples. So remember, if you need it, if it's important, explain it to people. And also, like GPUs in general, right? People know I need it because NVIDIA owns the world. Um, I need a GPU for my AI. What's your AI? What am I doing? Do you actually need a GPU? Do you need a desktop GPU? Do you need an HPC GPU? What are you trying to solve? So yeah, use your words carefully, explain it, make sure you understand the problem, what they're trying to do. Now let's go to another tool that can be helpful. Paraphrasing. So it's important that when you're trying to understand a complex problem, right? When you're listening to a person speaking to you and you don't understand, or maybe you do understand what they're trying to say, but don't parrot back to them what they said. If you just parrot back to them, you're not comprehending or trying to understand what they're trying to say. You need to paraphrase in your own words the part that you understand, right? So you don't want to just repeat to them what they said, but you need to try to paraphrase it and restate it in a way in your own words. Don't add jargon, and make sure the speaker then can confirm back to you or clarify your understanding. Because once again, right, you deal with many disciplines, many different researchers, different fields, and you can't assume that everything works the same way. Henry has a great example of that. Um, I'm sure it was yesterday, and the what is the oh man, Henry, the heaviest element in the solar system, right? So if you're talking to a physicist versus a chemist, it changes based on your perspective. So never assume you're talking about the same thing. Make sure you paraphrase it and um, give it back to the speaker. And the next tool, as you paraphrase, right, as you're listening, you want to understand and help solve their problem. So not only paraphrase, but then ask clarifying questions to get more information, and that'll help you to solve the problem, right? So what programming language does your software use? Do you have an account or a system? Have you ever tried this approach before? So get into the clarifying questions and how this will help you solve their problem. Let's do another chatter. So think of a clarifying question you could ask during an interview for one of these first contact researchers you are trying to help. So let's open your chat. Think of a clarifying question, and then I'm going to count down in three, two, one, go. Who is doing the work, the PI or some graduate students? Have you used your personal computer resources for any of these problems? I like that Dirk said why/who. Do you know the resources your computation requires, such as the memory or the time needed or computational systems? Have you run into any issues with the scale of your problem on your personal computer or workstation? What's your motivation for moving to high performance computing resources? Can you describe what done looks like to you? How large is your expected data set? That's good. Data is always a question. Are there any specific challenges? Languages, algorithms, systems have you considered? Is it worth exploring the efficiency, or are we already at a point that we just need to throw bigger hardware at it? I like this one. Does your data set contain PII, personal identifiable information? I always ask about the data. Storage is often just as important as compute. So for my background, I work at a research hospital. So our our first question is, do you have PHI, or is it a de-identified data set? That's always where we start. It's the data. And also comparison. So I went from universities to a research hospital, and they kept talking about big data, how much data they have. And the one day I asked, so how, like, I assume petabytes, large amounts of data. And so how big is the medical record system you guys have? Like, it stores all the information for all the patients at all the hospitals. They're like, oh, it's gigantic. I'm like, well, how big? It's 24 terabytes. I'm like, we have a different definition of size of data. So make sure, right? Don't assume things, even if you think you know what's going on about people, their data, their compute. How will you be sharing your code data in the long term? That's good too, especially if you guys have repositories and ways to, if you have Git repos you can have, or if they have, well, oftentimes with proposals and grants, you are required to have a public way to share your data, your data sets after the fact so people can get to them for especially publications. All right, good chatter. And then there's also from Henry, you can also say no without saying no. You never say, no, I can't help you with that. You say, instead of no, because, instead say, yes, if. And this is a quote from Henry, who I believe got it from, as Dirk says, Dan Boatwright, who got it from, we're not sure, but never say no, right? You're here to help. You are the person who is going to not, if you can't solve the problem, point them in the direction they can go to solve the problem. It's not, let's say the computing system is not for you, but is it, if it's not my job, you still need to have a relationship, right? This is someone you're going to work with at your university or your place of business. So you want to make sure it can help for future problems. And so always do a soft handoff. You should know people who can help to do the handoff, or find someone who can help. Or if you have to, right, you can be I'll do an acronym, LMGFY. Let me Google that for you. I forgot the T. Um, right, so your job is not just to hand off, but keep the relationship for future times. Okay. So when you stop, or when you're done with the intake interview, make sure, like most things, right, you have action items and follow-up time. So your job is not to say, we're done here. Make sure if you have an action item to check on, or they do they have an account? Check on what their storage capacity is, their data, what algorithm you're using, what's going on. And if you have items too, make sure you have that, and then set up a follow-up time to uh, get back with them to see what the next steps are to help them with their problem. All right, so we're going to, like how Dirk says, fake examples. These are real examples of intake interviews that Dirk has set up. And so when these videos are playing, let's keep your chat window open. And if things come to mind while you're watching the video, especially what we just talked about with these tools and examples, just chat your thoughts into the chat window. What do you like about this intake interview. What don't you like? The tools that were used during the interview, questions you would have asked, or questions you have about this or the interview. So just keep that chat going while I think we have 4 examples of different types and styles of interviews. And this is where we're going to also meet Dirk's alter ego. And just for reference, the stories, names, characters, these are all fictitious in relation to the real world. People or events is entirely a coincidence. And also, if you did not know, please also grade Dirk on his acting quality. He likes to have feedback on some of his work, so make sure you put that in the chat too, so Dirk can understand some of his gravitas and his acting. So here we go. So the first one is the Sanborn starter method. I'm going to play this and let's make sure the audio works. And open your chat window and please share your thoughts. Here we go.
Hello, thank you for taking time out of your schedule to meet with me. I really appreciate, I really need your help. My name is Dana, and you are?
My name is Jesse. Hi, Dana. Thanks for
Hi,
reaching
nice to
out.
meet you, Jesse.
Yeah.
Okay, I'm very frustrated. I have a lot of data I need to process using the Sanborn Strata method, which is better than the more common FCFD method. However, my transient error is much larger than my latent error. I think I can reduce the transient error, but I need to increase the Talholm threshold. But then the software doesn't run on my computer. So I need to make it run on the supercomputer. I was told you were the person to talk to.
Oh, Dana, I'm sorry to hear that. It sounds like you've got a cascading problems here. What is your timeline right now? Are you do you need, how are things working out for you right now?
I mean, really, we've got a paper we're writing. We can't get the results that we need. I would like to submit that paper in a couple months. I have a grad student who's starting this process, but we just can't even get the software to run because the computers are too slow.
Well, we need to get you back on track. My job here in research cyber infrastructure is to, try to solve or figure out where your problems reside and see if we can't bring some clarity to work through these problems. You threw a lot at me in that call. What specifically can you describe the systems that are running these calculations right now for me again?
Oh, it's my this computer I'm talking to you on. It's my Windows machine.
Okay, so you're working off of a laptop. Are you connecting to a larger compute node, or are you just?
No, this is a desktop. It was pretty powerful. I bought it a few years ago, but I had my graduate student pick it out for us. It has lots of memory and lots of cores. It's about 4 years old.
Okay.
It was top of the line then. It cost us something like $10,000. I can't give you the specs. My grad student could, but it was an expensive computer. And it so far has been doing amazing work. It's just when we increase that Talholm threshold, it just grinds everything to a halt and nothing works anymore. And the math doesn't get going. And we just need the supercomputer. All I really needed is to just take our software and run it on the supercomputer. Because I just needed to go faster.
So who's responsible for writing that code? Is that the work that you're doing, or is that your grad student?
Well, I mean, these are all standard methods. So my grad student typed them up in MATLAB.
Okay.
And then we run MATLAB on this computer. Like I said, they're pretty standard methods. We're not doing anything crazy outside of my field. But it's well known that as you crank up that Talholm threshold, computation just grinds to a halt. And so
I see.
We have been leading the pack in our research area, mostly because of this desktop that has been powerful enough. But then I was told that the supercomputer's on campus, and so we just need to use the bigger computer.
You need to move to the bigger computer. Now, can you think back to what the last time you were able to successfully run this code?
Oh, I mean, I can run it now at a lower Talholm threshold.
I see.
But once you creep it up past 0.7 or 0.8, you're done.
I see. And are you using your parallel computing? Have you explored any of that work?
Well, I do know this computer has, I think, 16 or 20 cores. I can't remember what they bought. So that they told me that makes it run faster.
I see. Okay. Well, it sounds like what we need to do then, if you're noticing that threshold change is what's locking out your code. So we need to get you in front of a resource to sit down and review that code to see if there's a way that we can get it to better utilize the processors that you have.
Okay.
And
why not use the supercomputer?
I think that what we're going to find is the supercomputer is going to provide you the same results.
But why wouldn't the bigger computer run faster?
Well, we don't know that for sure yet. And I think that it's, if you're telling me that the threshold, as you edit that threshold, I think what we may have to, sounds like you've got quite a few resources on that machine already. And my sense is we might be able to get a resource in there to help you optimize that code. And then we can see about how to transfer that to the supercomputer would be one option. I think what we want to do is look at your code locally and see if we can isolate a problem there first before we introduce an entire new environment. Then we will lose understanding of control over additional variables if we just move right to the supercomputer. I think the best approach would be to work with the resources you have and the team that you have currently.
So I have 20 cores on my computer, and I was told that the supercomputer has 10,000 cores. It seems to me that I should be able to do a problem 1,000 times bigger on the bigger computer.
Yeah, that makes complete sense to me, Dana. I think that we should, I just don't know the answer to that. And I think we need to start first with your resources and with your students and take a look at that code. And let's get a person in to give you another set of eyes on that code and see if indeed we can't add just a little more resources or add up that calculation a little bit more and see if we can get that running again on your machine, and then reach out to the supercomputer to see if indeed we can take that code and move it to the supercomputer. But first, let's look at your existing resources before we jump.
Oh, you're the expert. Thank you for helping me with this.
Not a problem. I enjoy this. Thank you very much for reaching out, and let's get another call scheduled.
Perfect.
Great.
All right, let's go to the chat. So I like the one is, I'm not sure what the Sanborn method is. And first, it's a Sanborn Strata method, and it's completely made up. That is the best part about this first interview, is everything in this was completely made up, but that does not change the fact of how you do an intake interview. So this is a good point of, if you don't know what it is, ask a clarifying question. So let's go through some of our chat. So let's see your stream of consciousness. I like the one, I suggest rewriting the code in C. So that's very good. And paraphrasing back to the user, right? You're trying to figure out, if you don't understand what they're talking about, you need to paraphrase it back. Let's go back to acknowledge the frustrations, right? Make sure you understand that you know they're frustrated. What they're trying to do is not working for them. And I like this one. No idea what this person is talking about. Need them to explain in a way we can understand. So, right, make sure they know that you're trying to paraphrase back to them, ask them for clarifying questions, because you don't know what the Sanborn Strata method is. I'm hearing you to access the supercomputer. Let's work on getting you set up. What's a limiting factor here? Memory, compute, storage. Here's one. I would have a different approach. The researcher wants a supercomputer, so why not give it to him? And then if the same problem, the new suggestion proposed by the facilitator. So right, there's different ways to approach this, and some of this depends on your resources at your university or place of work. So, at Michigan State and larger research institutes, they might have more resources and people who can take the time and help out with the software and make sure they check on their machine first to see how it works. And someone else mentioned here profiling, right? So not regular people can profile or even know how to profile, especially across different languages. But if your university is large enough, you have enough people who are skilled enough to go first check out what they're doing now is sometimes very important before you try to lift and shift from a Windows machine on someone's desktop to a Linux supercomputer and see what changes. You can, right, depending on your side, if that's a researcher's job and not your job, and you're there to support resources and hopefully give them on resources, that's one thing. But if you're trying to solve their problem and make sure that they're successful, you need to make sure that what they're doing can help them solve the problem. And the supercomputer might be the way it solves a problem, but your first question has to be, what if they get there and it does not, it's not easy to port to the supercomputer, or they get the different answers. I'll tell you a story about that. When I was working at Florida State, there was a researcher who came to us. He says, "Oh, I'm getting the wrong answer. We have to do this thing with my code to make it give me the right answer. My answers are wrong." And he was a researcher who forecast hurricanes. He was getting different hurricane tracks running on the supercomputer. Yeah, and it turns out, right, it wasn't just that the way he did it on his desktop when he first compiled the code versus on the supercomputer, slight variations in precision changes mathematics and rounding and things. So you can never assume that just porting to a supercomputer will make you have the same work as you did on your desktop. So you, as a support personnel person for their research, want to make sure that not only what's the problem, right? Just not porting the supercomputer, making sure they still have the same work, same output, same everything. And that might not be your job, but make sure they understand that they should test and verify as they do things. So it's not just faster, it's also right the same workflow, same answers. Let's see, what else? Also, basic follow-up question: does their code require any licenses? Right. The first thing the guy said in there, or Dirk, his name was a Dirk in there. His name was Dana. I use MATLAB. Do you guys have, is MATLAB a licensed thing on the cluster? Is this just something that a department or he has a personal MATLAB license for? That's a very good question. Man, that person, right, was looking good. You know, he's a dapper man. But I want to tell you, just wait, it gets better. Surprisingly, despite being called supercomputer, can actually be the case that code runs slower on the supercomputer unless they can be split across cores and nodes and have been fine-tuned to the specific nature on that supercomputer hardware. Glad you got the joke. Yeah, fortunately, MATLAB is amazingly portable, but it's true MATLAB also has a lot of parallel functionality built in. So if you run on a desktop, you can actually port their algorithms to parallel very easily as long as you paid for the license for their parallel code. All right, I like this one. You highlight our services might not be the correct answer. We had a group that was telling us the code was running slower on our system compared to another university. Turns out they were actively making adjustments to the code and not running the same thing on both systems. No wonder there were differences. Yeah, clarifying questions, make sure you dig into the details because details matter. Yeah, first question. It runs on Windows. Does the software version run on Linux? Right? Dana mentioned MATLAB, but is it MATLAB wrapped in Python, wrapped in something else? How many different codes run their program? Try to add the grad student who wrote the code to the call if possible, right? That could be a follow-up question if someone who wrote the code to be part of the conversation. Facilitator is mentioning parallel computing right away, which is a bit too much to assume the researcher knows about this approach and how to apply it to their own problems. They mentioned the core count of the workstation, but right, you can say I have a 20-core machine, but is your software actually using all the cores? Is it using parallel computing? Those are good questions to follow up with. recovering MATLAB programming here. MATLAB can be compiled into runtime without the need for license. That is true, but once again, you got to pay for the license in MATLAB to be able to compile your code. Because MATLAB, like most places, they want to be paid for their software. Matrices are very efficient data structure. I like this. So this is a great chatter about this first contact. And you are correct, the Sanborn-Strata method. We've got to know more about that, Dirk. We need to have a deeper dive for a future Cyber Ambassadors talk. All right, let's move on to our next example. All right, so was this scenario realistic? Yes, it was. Did Jesse sufficiently understand the problem? Did Jesse solve the problem? How was the relationship? And then other thoughts about the scenario. I guess put some of those into the chat. Did Jesse solve the problem? And did he ask enough questions to understand the problem? Yeah, I like that one. I have the scenario weekly. It's pretty realistic. So kudos to Dirk, way to make up something that is actually exactly like the everyday weekly scenario for people. And I want to say Dirk has been doing this for a long time. He has seen more than most of us will see, understands the complexity, especially MSU, right? A very large academic institution with diversity of researchers and backgrounds. He's seen it all and done it all, which is why he built the program about how to do it better. Which is why we have people like Henry and Dirk doing these amazing trainings and facilitations. All right, any more chatter about, do you think Jesse sufficiently understood the problem? And solving the problem, right? It's your first contact. Your job first contact is not to really solve the problem unless it's super easy. Is what are our next steps? What are we going to do? Do I understand the problem, the question, and keep that relationship for future? And Jesse did say, right, let's schedule another time. Let's get back together. Let's get someone there to look at your code with you on your desktop. I'd say Jesse did not understand nor need to the research problem. Instead, understood the researcher does not yet know enough about the computational aspect to make the jump to HPC. Maintain the relationship by offering to work with the researcher to improve the local workstation performance. Right, and if you have those resources, that's a great first step. If you can understand and solve there, and then port, that would be great. Jesse was oriented and kept his composure. That's very good too, right? You don't let the emotions. You're there to help them. And okay, thank you, Dirk. Let's keep moving. Our next one, we have our GIS data. Here we go.
Hey, my name's Jasper. I work here at our local high performance computing center. How can I help you today?
Hey, Jasper. My name is Jamie, and I am in need of some desperate help right now. I am a faculty member in the remote sensing department, and I am working through a whole bunch of imagery. And what I'm trying to do is some experimental analysis, and we've got a whole bunch of imagery. We're talking about 10,000 images inputs right now that we need to do processing on. And we had this working, and we had our algorithm set up, and we were processing this data just fine. And now we've upped the ante, and we have more inputs now that we need to put in there. And things are just slowing way down, and I need some help and to figure out how we can keep moving forward. And I'm feeling like the supercomputer might be my answer.
So can you tell me more about your analysis? I mean, how long does it take to currently process your images, and what kind of computer are you running on?
You know, we're running on the state-of-the-art Windows machine. We've added as much RAM as we can to the machine. We've got the video cards. We have cooling systems in there. We're ready to go. The second, we had it's about 10 minutes per image that it has to go through pixel by pixel and to do comparisons and analysis. And we are, we've never used a supercomputer before, but we just know it's got to be the answer to our problem.
So when I hear image data, one thing that comes to mind is the results of one image dependent on the results of another image? Are they independent results? Does that make sense to you? So does it matter which order I process the images in?
It doesn't. It doesn't matter. We've got a set of algorithms on each that are looking for they're looking at the patterns in each image, and they're off-putting data into the statistics that are valuable metadata for each image.
No, that's good. So if it was like a video where, one frame depended on a previous frame, it gets harder. But with independent analyses, that means we can run them on separate computers at the same time. And we call that parallel processing. So,
okay.
So if you're saying it takes 10 minutes to run a single image, if I do that calculation, which I did on my little Google calculator here, it will 10,000 images will take approximately 65 days to run the way you have it written.
Yeah.
Now, that's where your slowness has come. Now, there's lots of options that we could consider. One is there anything we can do to optimize the code? It sounds like you got a very good desktop computer with a lot of resources, and you're probably not utilizing all those resources effectively. So we could look at the code and try to optimize it. That could be one thing to do. But since it's giving you analyses that you want, the other thing to do is we might be able to port it to the high performance computing center. And our system, a standard allocation can run on 500 computers. And so now your 10 minutes per image of 10,000 image divided by 500 computers means we could run it in about 3.5 hours.
Oh, that would be fantastic.
What I like about that is that doesn't break your current code, right? If it works on your computer. Now, I don't know if it will port over. You said you're running on Windows.
Yeah.
HPC runs on Linux. So we'll have to look in that. There's also a possibility that there's some efficiencies in the code that we could add that might solve all of our problems, and you can continue to use yours. But these are the types of things I want to look at with you.
Okay.
And so, yes, we can do that. Does that seem like a reasonable
But Jasper,
solution?
that sounds expensive. Is this something that you have resources that can help me with this?
So
I've only got a few $1,000s left in my grant.
So that's very wise. So right now, the HPC on our campus is free for all researchers.
Okay.
But up to a limit. There are also national resources that are free through the National Science Foundation called Exceed resources. We can get you on those if we need to. There are lots of free resources. Some of them require, like the Exceed requires you to write a short proposal, that kind of thing. But they're very large resources, and we might be able to do that. So
well, it was my grad student that wrote the code, so that's that he's off on an internship. That's not. Can you guys help me with that code?
Well, we don't have coders in our lab, but I would be happy to spend a few minutes looking through it with you, because my expertise is coding. I will not be rewriting it for you, but I should be able to identify if there is some obvious problems with the code or obvious speed ups that we can make.
Okay.
And I'll do that for anybody on campus, right? Give me about an hour with you in the room, and we'll look at the code together, and I'll see if I can see anything obvious. If not, we can still run on the HPC. Even if it's non-optimal, we can get it down to 3 hours instead of 65 days.
Yeah, that would be a great start for us. Thank you, Jasper.
Yeah, happy to help you, Jesse. And I hope to see you soon. Let's reschedule a meeting quickly and have you, let's look at your code.
Great, thank you.
All right, that was our GIS example. And let's get to the questions in the chat. Let me open the chat up. And as Dirk said in the chat, this is an older video which references Exceed, which is now replaced by Access, which is our national supercomputing resources. And I had to look up what Access stands for. It's the Advanced Cyber Infrastructure Coordination Ecosystem Services and Support, which is funny that I had no idea or did not know what Access stood for. Let's go through some of our messages. All right, so this time Jamie was the researcher and Jasper was the research facilitator trying to understand, or sorry, Jamie was the research facilitator, Dirk, and Jasper was the researcher. And here's some questions. Like, what is the estimated size of each image? Right, image by image sounds like it's ideally parallel, and the facilitator caught on asking about this without introducing unnecessary jargon. And then used what I like the example of like a video, right? Each frame depends on the next frame versus an independent image where the data from one frame does not depend on the previous image. So you can do it in what they term sometimes people say embarrassingly parallel, which means they're not dependent on each other, independent analysis. And the facilitator is doing a good job of understanding the problem, explaining why code optimization is the right approach. Um, right, in the previous example was not as clear. It was a very difficult one to understand. And this is a good point. I will not be writing the code for you. It's important to make clear what you will and won't do for your research or what you have the resources to do. Okay, so embarrassing parallel, pleasantly parallel. That's correct new adjective for independent processing. Other thing to do is you one thing you should note is in the video is he promised like a 3 hour or time from whatever it is to 3 hours, and you never know for certain until you're in your system what time it can be. So you can promise speed up, but just be careful you don't promise too much speed up, because when you're setting an expectation, you might not know because this is your first intake interview. You're not quite sure how the image analysis does or compared to their desktop versus your supercomputer, how they're running. And the other thing too is setting expectations on your resources. For this example, right, there are free resources for the researcher to use because like he mentioned, I have very little amount of money left in my grant for this. A lot of places do charge researchers for access to HPC. So make sure that is understood too and how they can use your resources. And also, that's a good point. How large input output is like 10,000 images. How big are your images? Are they tiny? Are they large? Are we talking about data options? And then once again, a lot of supercomputer HPC resources have limited data storage because it's expensive. They might have a large scratch space, but if this person needs to keep the data somewhere, make sure you go over those things, understand the problem. That's their goal here. Understand the problem and make this a relationship so you learn more about what they do, how they do it, and how you can help them. And these are good. What other, and then let's see. We think so. We think Jasper did sufficiently understand the research. He paraphrased back. He gave examples about right image and the independent nature of the images and how to parallelize them. Did he solve the problem? He did the next steps. Next steps were, what do we do next to test and help you to see how we speed up your thing? Then he set expectations. Any other thoughts about the scenario? Or are we good to go on to, this is my next example is my favorite one, and you'll see why in a second. So let's move on to, this is the GIS data take 2. And once again, in the chat box, keep your questions in and the comments coming. So this is my favorite Dirk alter ego. Here we go.
Welcome to my office hours. How can I help you today?
Hi, my name is Jamie, and I am a faculty member in the remote sensing department, and I could really use some help. I'm running some compute on some satellite imagery, and it's just not working out for me. My resources are locking up, and I need to talk through a way to move this to the supercomputer.
Okay, can you tell me a little bit more about what kind of calculation you're doing?
Yeah, I've got thousands of satellite imagery. I'm doing comparisons of their pixel values. We're doing some nearest neighbor calculations. We're looking at all of this data, and we're trying to seek out some reflectance values that will help us with some climate change data that we're deriving from this. And we're just getting more and more data, and it's just getting more and more complicated. I have a state-of-the-art machine in my office with some GPUs and some great cores that are helping us get this work calculated. And the more data we add, the more cumbersome it gets.
So why do you think moving the supercomputer is going to help you?
Because it's super, right? It's got more.
It is.
It has, you guys, there's more resources, and it just felt like I needed to throw more resources at this algorithm to make it push through. And we're getting more. We're getting some great feedback in our analysis approach, and so I'm expecting thousands of more imagery that we'll be able to put into this process. And so our initial white papers on this are getting some good feedback, and we're ready to start to expand this. And the more I expand it locally on our machine, the more trouble I get with the compute time.
Excellent. So all you need to do is fill out our form to get an account, and then you can use standard SCP to upload whatever code and files you need to the computer. And then we'll have you write a Slurm script, and you can submit a job, and you'll be up and running in no time.
My graduate students are in the field for the summer. That's not, so being able just to hand off the, upload code is not going to work for me.
So what do you need? I mean, it's pretty straightforward stuff.
Well, it doesn't sound like it. It sounds like you're asking me to do all the work here. Are you, what's SAP? What's, do you need an account number? Is there a cost associated with this work?
So using our local HPC is free, but you have to use it. It's a supercomputer. It's not an average person computer.
Okay.
You need to use, you need to get an account. You need to log in. It's all free. We have a wiki, and we have a bunch of videos on how to use the system. Just watch those videos. You'll get on, and you should be, it sounds like your system should be pretty easy. And if you, have problems, you can submit a ticket to our ticketing system.
Okay. So this is a free resource, and, I've been doing a lot of research, and I have a lot of, indirect costs come from my grants that I thought helped pay for these types of resources. And now you're telling me to just get in line and fill out a ticket? Is that what we're doing here?
Yeah. So it's all free. We just provide, you log in. We have a pretty standard interface. And if you're not familiar with it, you could go to one of our tutorials, which are fairly regular. And if not, we have some online tutorial help. I mean, it is a supercomputer. It is not easy, but it's pretty straightforward. If you're running it on your local computer, a savvy programmer should be able to have no problem porting it to the HPC.
Okay. All right. Well, I have some collaborators at other universities that, have some resources. So maybe I'll work with them to look for another solution to this problem.
Oh, that sounds like a great idea.
Okay. Well, thanks for your time, I guess.
All right. You take care.
Bye.
All right. First, froze for me too. Can you guys hear me? Someone chat me back.
Yes.
Yeah, my video froze for some reason. All right, so you can hear me. You saw the video. Yes, and it froze for a second too. And I even plugged in an actual Ethernet cable to make sure I had a more stable connection. But you never know the interwebs. So let's go through our chat. So our questions for our last interview. First, the first thing you need to note is Dirk's alter ego. This is my favorite one. And was this scenario realistic? I will tell you right now, this is a realistic scenario. And the worst part is I've seen this, and it's more common in larger shops that have ticketing systems, and they want to hide their personnel from front-end researchers because they think that tickets and closing tickets and queues and things are more important than the relationship and doing that. So it is very scary to watch this, but this is sometimes common in some larger shops and things. So right, let's look at some of the things you guys commented on. Yeah. Oh, pretty straightforward stuff. Is that a good thing to say? Um, Acronyms, SCP, slurm, job, you may not know. Um, yeah, definitely not meeting the researcher where they are at. Condescending, self-sabotaging, just so bad.
Mhm.
Um, Not an average person computer. That's a good line, right? It's a supercomputer. It's not for the average person. Um, I'd rather not be talking to you or helping you. Several statements apply. If it's hard, then I must be dumb, right? What assumptions? What do people hear when what you're saying? Um, yeah, have dealt with hundreds of professors. Unfortunately, never had that happen. Usually, they only want you involved to get them going and be done. Um, so right. So did this facilitator understand the problem? Did they help solve the problem? And the big one is, did they maintain a relationship? This is right. There was nothing here that so they're trying to help, and it did not seem like they were even they were offering solutions like you can use it. Here you go. Let's go. So this was one of the best examples of try not to do anything from this research facilitation standpoint. Do the exact opposite. But no, it does happen, and no, and know that right, just because you create all the documentation and intake videos and how to do things and where you do stuff, it's really the connection and helping people understand that they might not know what you know, and just because um, how you learn or how someone else learns is different. So talking to someone or videos or documentation, try to meet them where they are, understand where they come from, and also know who you're talking with might not be the person who's doing the work either. Like someone said this in the chat before. It could be grad students, postdocs, someone else. This might just be your first to take interview for the professor or the grad student, and you need to know the full um, gamut of who's involved in what they do and how to help them. So I'd often a lot of times meet with the entire research lab and do it that way. We'd do a small little talk and then we talk about it. But yeah, try to involve people right where you start and get a full picture of everything's going on. So I think that was my favorite one. So that is the end. I think we have a couple minutes left, 2 minutes left in our session. So in the chat or you can actually audio turn your mic. If you have any questions about this training, please let me know. And Derek is here, the one who created this training, and I want to make sure you have for your memory a picture of Dirk's alter ego for that's the main thing I want you to get out of this entire talk was this is a sample of what the Cyber Masters does. And if you think this is important and you want to bring some of these skills to your team or someone else, please email Dirk or Katie, and there's the emails at the bottom. Yeah, so Colbry, KA at MSU.edu. And know that we do this with Henry too every ACRF. We love to do these talks, and please ask any questions. And thank you for your time. And also there it goes. So Dirk, his emails in the chat. It's Colbry, DI at MSU.edu. So it's Katie or Katie or Dirk. Yes, these videos are great. Make sure you comment on Dirk's acting. I mean, it is bar none some of the best cyber infrastructure acting I've ever seen. That's what I'm going to say. I mean, top two at least. Yesterday we heard a lot of facilitators are non-IT. However, much the intake interview requires a lot of IT understanding. How do you rectify this? It's a very funny question. So there's actually another NSF-sponsored thing called CCMNet, which is a cyber infrastructure mentoring network. And there are mentorships there that try to help facilitators who are non-IT learn some of the lingo. And I'm actually starting one of those right now. It's called, I'll send you the link in the chat. Let me pull it up. Can you still see my screen, the CCMNet?
Yes.
Okay. So ccmnet.org, facilitator, or there we go. What don't you know as a resource facilitator? So if you guys are curious what you don't know about things like slurms and things, enjoy my mentorship, which was not on my bingo card today to uh, to throw out there, but there you go. And this is something started with Marissa Brazil and Chris Rady from Arizona State. They have the same thing, right? They're recruiting research facilitators that are discipline specific, but they don't know a lot of HPC or knowledge about the cyber infrastructure. And so what do you do to learn those things? And I'm not going to teach this only. It's about also connecting you with other groups that will help you do this. And there's there's many cohorts of people who try to help you get into a better knowledge base for doing this. Just like Henry's thing here and Dirk's Cyber Ambassadors, there's all these programs that will help you get to that point to be better at what you do and what you know. So there's some more plugs for some NSF sponsored trainings. And I sent the link just to Dirk because I can't multitask in my chat and talking at the same time.
Hello.
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 8032789222. Again, our callback number is 8032789222.
Did we lose Dan?
I'm
All
still here.
right. Thank you, Dan.
I'm good. All right. Thank you.